remember the steps. So that's the tricky part with this one. Just gotta find a color. So the reason why we do this is because sometimes vertex form is a little bit easier to graph from because it gives you the vertex, it gives you the opening, it gives you whether it's a wide or narrow graph. The only thing it doesn't give you is the y-intercept. Maybe we'll try this first. Let's do this. Let's do a hard one right off the hop. Can you guys convert that to standard form? No? Don't feel like it? Nah. Okay, so we all know this is in vertex form, right? Where's my vertex on this one? 3 and 4. My vertex is at a positive 3 and a positive 4. Which way does my graph open? Down. How many x-intercepts do I have? 2. Okay, so there's lots of stuff you know right away about this graph. Lots of stuff you know. So sometimes vertex form is a little bit easier. The only thing you can't tell from this is the y-intercept without doing any math. So if we were to convert this to standard form, we're going to, order of operations says I do what's inside the brackets first. Well, I can't do anything with a variable and a constant, like I can't combine them. So the next thing is to do my exponents. And I would say that this is where a lot of my students struggle with. First of all, an invisible -1 out front. If it helps you, write that in. If it doesn't help you, that's okay. You can just leave it as a negative. It's whatever helps your brain remember the math. So I'm going to do exponents first. Now, the thing that people mess up on all the time is they go just ahead and they square this. And I think we did this in the review. So you have to expand this multiplying first. Right? So now when you're multiplying 3 things, you multiply 2 and get a product, and then you multiply the product by the third thing. So I'm going to multiply my 2 binomials first, because I'm pretty good at that. I'm going to leave my -1 right there. I'm going to have x squared minus 6x minus 6x plus 9 plus 4. Do you guys trust my math? My leapfrogging? We did this in grade 10, so hopefully you feel a little bit Guys, these aren't 6s, they're 3s. They're 3s. Thanks. I knew the answer was 6 when you put it together, so this is why you always draw the arrows in, because it helps your brain. Okay, so y equals -1 x squared minus 6x plus 9 plus 4. So order of operations says I got to do multiply next. There's no division, so I'm going to do multiply. So I'm going to multiply this -1 through the entire bracket. Hey, did you guys notice that I haven't lost my equal sign? My equal sign stayed all the way through. Don't lose that, because that's going to be a half-mark deduction, because you're switching between forms of an expression and an equation. So don't lose that. Keep that. So now I'm going to combine like terms. The only 2 terms that are like are those 2 right there, which are my constants. So y equals -1 x squared plus 6x minus 5. Where's my y-intercept? -5. There's a lot of math for -5. Could I have just used my vertex form and substituted 0 in here and done some math? Yeah, you totally could have done that as well. That would have worked as well. But sometimes you will be required to put it into standard form, so you do need to know how to do this. And that's just order of operations. But it gets a little bit complicated, so this isn't anywhere in your notes. I hope you all remember. Okay, so we're now doing the opposite. We're going from standard form and we're completing the square. Do you guys know what perfect squares are? Give me an example of a number that's a perfect square. 4. Anybody else have a different number? 9. Okay, all right, we got 4 and 9. Nobody's gonna be wild and crazy and do like
36.
Ooh, I like 100, I like 36. Okay, so you know your perfect squares. When we talk about perfect squares in algebra, yes it is. This is a perfect square. because the two factors are exactly the same. X minus 3 times x minus 3. We know that 4 is a perfect square because its factors are 2 and 2. They're exactly the same. Perfect squares are going to come into play. But we don't really need them. You just have to think about it. Okay, so step 1, we're going to group the x's together. We're going to do that by putting brackets around them. So we're going to group like an x squared and an x, and let's say there's a 4 there. We're going to group those together just like that. Easy peasy. We're going to remove just the coefficient if there is one on x squared. We're going to remove it by common factoring it out. Okay. Step 3, I call this my side note because I do this off on a scrap piece of paper or off on the side. It's kind of like math magic. Kind of like that negative b over 2a, like it's a formula that you kind of have to commit to memory. It's not really anywhere. You're going to take the coefficient of the x. What's the coefficient of this x? The invisible number 1. And we are going to divide it by 2. What's 1 divided by 2? 0.5. 1/2 if you're feeling crazy with fractions. And then you're going to square that. What's the square? What's easier to do? Can you square a decimal easier or can you square a fraction easier? I can totally do a fraction. So what's the square of 0.5? 0.25. 0.25. Good mathin'. And see, I do it in a fraction in my head. I'm like, that's 1 over 2. I'm going to square that. 1 squared is 1. 2 squared is 4. That's 1 over 4. Okay? Then you're going to add this number inside the bracket and you're going to subtract it from outside the bracket. Crazy, I know. The reason why we do it in 2 different places is because we don't want to change the value of the equation. We want to just change how it looks. Step 5, factor the perfect square. I'll teach you how to do that really quickly. Simplify the numbers outside the bracket, and ta-da, you're done. Easy peasy, right? You can totally do that. Okay. What's step 1? It's the easiest one. Group the x's together. Put brackets around the x's. That's all I want you to do. Easiest step 1. Now, step 2 says, it says remove, but really it should say common factor. Maybe let's go up and I don't like, factor out the coefficient on the x squared. What is the coefficient on the x squared? Still 1, right? So I don't really need to do anything here. I mean, I could put a 1 outside, but it doesn't change anything inside the bracket.
So we can factor out the x only the coefficient?
I only want the coefficient. This is the tricky part, because you think like, oh, I'm going to common factor, so I'll take an x out. Don't do that. It'll screw everything up. You'll cry. I'll cry. It'll be bad. At this point, I'm going to leave this big space in my bracket. Hi. Pardon? No, Miss Thorne is, I'm not sure where she is in the afternoon.
I left in here this morning.
Okay. Is it that poster over there?
Yep.
Perfect. Looked like it needed a home. All right, so I leave this big space and it's purposeful. Okay, so common factoring that out would have been 2, but I'm just taking the coefficient. And I'm writing these numbers on here just so you can see the steps that I'm doing. Okay, step 3 was the side note. Step 3, I'm putting that over here. I'm labeling it as my side note. It's just like a little scrap piece of paper. And we're going to take the coefficient on the x. What number is that? 6. We are going to then divide it by 2. What do you get? Brilliant. And then what are we going to do? This is the trick to get it to be a perfect square. So this is the stuff you have to remember. It's nowhere else. You've got to like stick it in your brain and remember it. Then we square it. So we're dividing by 2. So I'm going to highlight that 2 because it's always 2. Always divide by 2. That's the rule. And it just helps us make it into a perfect square. So 3 squared is 9. Good job, everybody. Okay, you're like, what do I do with that? Ooh, guys, I forgot something here. Forgot my plus 5. That was still in the equation. I just kind of like ignored it completely. Okay, so that's step 3. Step 4 was to take this 9 and we are going to add it inside the bracket.
What if it's negative?
And then we are going to, it won't be because you're going to square it. So anything that you square is going to be positive, but good question. So if it's a plus 9 out here, it's a minus 9 out there. And the reason why is because this has a value of 0. It's called the 0 principle. You can change how something looks, but you're not going to change the value of it. Okay, that's step 4. Okay, step 5. We're going to factor this. Can you guys go ahead and factor that trinomial? This was step 4. This was step 4. Okay, I want you to factor that. Just what I highlighted. What are the factors of 9 that will add up to 6? 3 and 3. So it would be x plus 3 times x plus 3. And if we combine these, that's going to be a negative 4. Correct? Everybody agree with me? Doesn't really look like vertex form yet. Wait, what?
Did you just take the root square factor thing?
Yep, we factored these. This factors into this.
So there's one more step in there though, right?
Yeah, we're not done yet. You're trying to rush this, Boomy. Just let it happen. Let it
Like
happen.
the middle one, like the 9 when you add it and then you write it down. You know what I mean?
No.
Like x
Oh, you mean like 9, the factors of 9 are 9 and 1, 3 and 3?
Yeah, so okay, so you're doing that one.
Sorry. Yeah. And the reason why we want it perfect, we want these two numbers to be the same, because we are now going to write it okay, where's my vertex? Negative 3, negative 4. Which way does my graph open? Up. How many x-intercepts? 2. Where's my y-intercept? Plus 5, because you had it. You already had it in standard form, right? So it was there. So you know an awful lot about this parabola by being able to convert back and forth. This gets harder. No, it doesn't get harder. All the steps stay exactly the same, but the numbers get not as nice. They get a little bit uglier. Sometimes we deal with fractions, things like that. I want to show you something. The quotient that you get here after you divide by 2 will always be the value inside that bracket. So you actually don't even need to know how to factor to do this. If you've done all your math right, this will always work. So if you divide and get a negative number here, then this would be like subtract 3. If you get a funky fraction like 7/2, which happens, this would be a positive 7/2 in here. Like, so the numbers will get uglier, but our math won't change, and we're gonna get really good at this. But it's gonna take some practice. Okay, let's do one with a coefficient in it. Okay, step 1, easiest step. Brackets. You have flipped the page, so now you got to remember all your steps. So step 1 was brackets. Step 2 was?
X, no,
Not yet. What do we got to get rid of? What are we going to factor out?
coefficient.
The coefficient on the x squared. Okay? See, I always like to leave that space. So you've done step 1 and step 2. And you do see how I took the 3 out, so I'm like dividing by 3, dividing by 3. That has to change to a 4. Like you have to take it out of both of the x terms. Don't just take it off the first one. That's a common error. So just keep that in mind. Step 3 is our side note. So our side note is going to be the coefficient on the x, which is -4. We're going to divide it by 2, always 2. And we're going to square the result. Ladies and gentlemen, I will always write this number down because that number is the magic number. That's the thing that goes inside the bracket. So I'm like, I can do this math in my head, but realistically, this number is helpful to us. So I'm going to always want to write it down. Okay, there's my side note. What do I do with that 4? Yeah, add in the bracket, subtract outside the bracket. Okay, now I'm going to add another layer for you. I'm going to add another layer just to mess with your heads. What does this 3 out front mean? It's a coefficient, but what does it mean I'm doing to all these terms? Times them by 3, I'm multiplying them by 3. Yeah. So really, what is this number if I times it by 3? 12. So if this one's times by 3, that one also has to be times by 3. Because you just told me that 3 times 4 gives me 12. If I add 12, what number do I have to take away? 12, because I can't change the value of it. So if you have a coefficient out here, it has to be also at the back of the bus. Front of the bus, back of the bus. Kind of like the earmuffs of the equation. All right, so now that was step 4 with an added layer, which isn't very nice of me to do. Step 5, you are going to factor. You're going to factor this. But I'm going to teach you how to do the lazy factoring. You're going to put some brackets. You're going to put a squared out here. Always going to be an x. What's going to go with it? The thing from your side note, the quotient from your side note is going to go there. And I mean, if you don't trust me, fair. You can always factor it and double check. And the reason why I'm trying to teach you the quick way is because sometimes we get some really ugly fractions and nobody's got time to factor those. Nobody. Not me, not you. There'll be a lot of crying. What happens out here? I got to simplify it. Bless you. Do you guys want to try the next one on your own? Give it a shot. Give it a shot on your own. Just try. And if you get stuck, you know I'm going to show you how to do it, so it's no big deal. What's leaking?
Maybe the table does.
Did you all get the first 2 steps? Did you remember to change that 3 to a plus? Yeah? Okay. Do you want fractions or decimals? Ooh, I like it.
It's 9.4.
9 and 4? 36. 8 times 4 is 32. She was right there. She was real close.
Well, that's 8 times 4, that's all.
Duh. Works the same way if you multiply 9 times 4.
Yeah.
You get 36. 36 divided by 4 is 9.
Can I cancel out if I'm adding 5 plus 36 over 4? Can I cancel out 36 and 4? Take my phone. Like, just like that. Can I cancel
Oh, yeah.
out?
Yeah, yeah, yeah.
Maybe my phone. No, break it.
Okay, how did you feel about the fractions?
Pretty good.
Wait, why did, when you did the plus 9 over 4 at the top, why
Mhm.
did you do the negative? Like a negative one, like the outside. So would that turn into like a negative?
What? Okay, I'm not.
Like the fraction inside? Or do it
This one
swap?
inside?
Yeah.
Well, when I took 3 and divided it by 2, it gave me a positive number.
Okay.
So it's always, like what's going to go in here is always the added one, and what always goes on the outside is the subtracted one. Because anytime you square something, if you take a negative number and square it, you take a positive number and square it, you're always going to get positive. So always add inside the bracket, always subtract outside the bracket. I see what you're saying now. I gotcha. I just caught up. You're saying, hey, if I multiplied that through, that would be negative, right?
Yeah.
I get what you're saying now. But if I take a negative and a negative, what do I get? That becomes a positive, right? So yeah, it works. So I always add inside, always subtract outside, and it will work. So were you close? Yeah? Yeah? Did you get the Okay. This one was harder. It's got fractions in it. It's uncomfortable. We did our best. How much do you guys like the quick factoring?
Really?
That's handy. You just got to remember it's the 3/2, not the 9/4. It's the first one. Okay.
So if we get that wrong, everything's wrong.
Technically, yes, your equation is wrong. But what we do in math is we call follow-through errors. We call them follow-through errors. So if you made a mistake here, like you wouldn't get the mark for the correct x coordinate of the vertex. But if you had to do more work with this, which you will in some questions, we take the wrong answer and make sure the rest of the math is correct, and you get full marks for those. We're not going to ding you 2 or 3 times just for one mistake. Unless I'm really mad, and then I'm having a bad day, you guys. Okay. It's pretty exciting. Do you guys know how to divide fractions?
Reciprocal and then times.
Can you guys grab your calculator? And can you take 4 and divide it by 0.5? Just do it in your calculator. It is. She's smart. She knows. Yeah, for sure. Hopefully you're going to get 8. Hopefully. Let's do that fraction way. We don't divide fractions, we multiply by the reciprocal. Same thing. It's a really hard concept for people to grasp. That when you're dividing by a decimal, you get a bigger number. We'll get there. Okay, this one's a little bit different because what's it missing? The y-intercept. It's not missing the y-intercept, we're not writing it, so where's the y-intercept? 0, okay? Not a huge problem. I've grouped my x's, and that's all I have are x's. So that means I'm dividing each term by -1/2. So I'm going to have x squared and if it really makes you happy, put a 0 in. If it doesn't matter to you, then don't. I'm okay with that. Can you guys solve it from here? Okay. I didn't do a lot of math on the page there, but I had to know an awful lot of stuff to do that.
Why do you have -4?
-8 divided by 2 is, and that's why I said it's really important that you make sure you're taking the sign and you actually write that down. Okay, last one, super ugly numbers, but I'd like you to try it. So I'm gonna hit pause on my screen. You guys are gonna do it. I think you should try it. I even gave you the answer. It's right there. It's right there.
Okay, we got it. And 5 minutes.
We only have 5 minutes to do this? Have I really run out of class time?
3. Can you actually do arithmetic?
Okay, they're not that ugly of numbers.
I have funny. I have funny.
Whoa. Left unsupervised, you knock everything around. Can I show you the answer? Or are you still working? Okay. Well, I guess you know the answer, but I just wanted to show you the steps. Pardon? Nope.
Here. What? It's not. They can't put me short. Oh, they didn't have to get short.
Simplifying fractions is something that is a good habit to get into. Reducing fractions, so I don't have to pull out my calculator. Like, so instead of timesing 4 by 49, I mean, I have to think about that. I can just go, hey, the denominator of 4 goes into 4 one time, and I just simplify it that way. It just allows me to do quicker math, dealing with smaller numbers. Some of you guys have super strong number sense, and that is awesome. So whatever method works best for you, just know that our goal in this class is to move away from relying on our calculators. And if you're going to go into an engineering field, or you're going to go into one of the pure math courses, you're probably in university, like calculus, you don't get a calculator, linear math, you don't get a calculator. Like, I just, it just becomes where, and it's actually nicer, because the questions, you've gone wrong because nobody's going to ask you to divide 17 by 243 on a non-calculator thing, right?
They might.
I doubt it.